research review. So we have one trigram at a time, XSLeak via universal CSS injection in DoS and Opera GX by zhero. So this is interesting. I'm about it. This should be fun. It's from the title, it sounds funny. I'm interested in what the universal CSS injection vector is. The DoS part's pretty clear. I can think of a lot of ways to crash the page via expensive CSS. I think even just expensive selectors. You don't even need to bring in like billion laughs SVG images, but alright. One trigram at a time, XSLeak via universal CSS injection in DoS and Opera GX. Yeah, so same words, but like on a cool image. Introduction. This paper focuses on a critical browser vulnerability discovered in Opera GX that allows cross-site data exfiltration simply by visiting an attacker-controlled website without requiring any user interaction. By abusing the browser's GX mods feature, what initially appears to be a harmless customization mechanism can be turned into a universal CSS injection affecting every web page visited by the user. Nice. Yeah, I don't know about Opera GX. Like, I know that like they're like trying to sell to they're trying to cater to a demographic, and I don't know. I have no idea what the source is. It open source? What are the? It's a Chromium fork, so does it have to be? How does the Chromium licensing work? I don't know. Okay, they have a program on BugCrowd. That's interesting. Okay, I have a bingo card item that might be relevant to this, but on topic. As we will see, this makes it possible to build a practical XSLeak capable of exfiltrating sensitive information from arbitrary websites. Same attack vector also enables a denial of service attack affecting both Opera GX and Opera. Yeah, this is nice because if you can get universal CSS injection affecting every web page, it's like you don't have to care about like CSPs at all because it's just like, can I impact some page with no CSP? Yes. Or any arbitrary page with no CSP? That's a problem. Which means you get like, because when I'm doing CSS injections, it's like usually with a pretty strict CSP, and it's like, oh man, I can't even use sequential import chaining because I only have like inline styles, and I have to like font leak it or worse. But this sounds like it'll be less painful. I hope. I don't know. We'll see what the constraints look like. There might still be some serious constraints, but the vulnerability was responsibly reported through Opera's bug bounty program and resolved prior to publication. During our collaboration, the Opera security team was responsive and transparent, which greatly facilitated the disclosure process. Let's dive in. Okay. Mods feature on Opera GX. To start, on Opera GX, the GX mods feature lets you customize your browser by changing its appearance, sound, animation, and even the look of certain websites, with the ability to create and share your own mods. The GX mod essentially consists of a folder containing a manifest.json file which defines the mod's metadata and customization features, along with the assets referenced by the manifest. Although GX mods share some similarities with standard browser extensions, including the fact that they are packaged as CRX files, they are not regular extensions. They have no browser permissions and do not support JavaScript execution. Instead, they are limited to customization assets such as browser sounds, background music, wallpapers, themes, shaders, and CSS files. Okay, that's a very interesting attack surface. Initial observations. Our investigation began with a rather surprising behavior. When a GX mod is downloaded, it is automatically installed without any user permission prompt. What? As a result, an attacker can install an arbitrary GX mod on any user visiting a malicious website without requiring any user interaction. For example, by simply embedding an iframe whose source points to an arbitrary CRX file. That's actually crazy. That's great attack surface. Then it went from like cool attack surface to like, yeah, dude, definitely hack them. The only indication shown to the user is a notification bar displayed below the address bar informing them that the mod has been added. After some research, we discovered that the well-known security researcher Renoir had already identified this behavior in 2023. Nice. He leveraged it to spoof the entire address bar by a moment of silence for Renoir, because I think he's frustrated right now with things. He'll be back. He'll publish some great research, but alright, we can't do a moment of silence. He leveraged it to spoof the entire address bar by abusing the automatic update mechanism to transform and install a GX mod into a regular browser extension. Whoa. Wait, what? That's crazy. But couldn't you just get like UXSS at that point if it's a regular browser extension? Oh, okay. Although the resulting extension still had no explicit permissions. Okay, there we go. You could execute a background service worker and use extension APIs available by default, most notably Chrome.Windows, to perform the attack. Okay. He responsibly disclosed the vulnerability to the Opera security team and later published his research, which we encourage you to read. The vulnerability was patched on March 5th, 2023. The ability to arbitrarily install a GX mod by simply visiting a website is an interesting attack primitive on its own, but does not appear to be particularly useful. It was therefore reasonable to assume that since Opera had not patched this behavior even after patching around most vulnerability, which also relied on this primitive, the most promising exploitation paths had already been closed. Fortunately, security research rarely rewards reasonable assumptions, so we kept digging. That's a lot, but true. Unexpected state in browser denial of service. OperaGX is based on Chromium, and Chromium does not allow by default extensions to run in incognito mode in order to preserve the privacy guarantees of private browsing. As we have seen on regular extensions, GX mods are automatically downloaded and installed. This naturally raises the following question: what happens if a mod is automatically installed in incognito mode using the previously described primitive? Can this force the browser into an unexpected state? The answer is yes. The browser crashes and restarts, resulting in the complete loss of the current browsing session, including all open tabs. Simply visiting a link pointing directly to a CRX file or a website, embedding it via an iframe as described earlier, is sufficient to trigger a browser crash. Okay. The denial of service issue described above affects both Opera and OperaGX. Although Opera does not support GX mods, the vulnerability is not specific to mods. Any file with a .crx extension triggers the extension installation pipeline regardless of its actual context. As a result, simply visiting a link that downloads a CRX file in incognito mode is sufficient to cause the browser to crash. That's crazy. Okay, I have a lot of thoughts here. That's, shocking. Possibilities and limitations. Although we had initially skimmed the documentation to understand what could be achieved with GX mods and gather some inspiration, we had not fully realized their capabilities. It was only after experimenting with the feature that everything clicked. A mod CSS can be applied to every page and tab. In practice, this means that attacker-controlled CSS is applied across arbitrary web pages visited by the user, giving it access to a far broader browser context than a conventional CSS injection vulnerability. Yeah, why? Why not just type red? Like, come on, man. You like that shade of red? Is that your favorite color? I guess it might actually be. All right. Is that kind of what we're going for here? No, it's not the same shade because that has lower zeros. Okay, whatever. Although CSS injection can be a powerful primitive for data exfiltration when XSS is not possible, its impact is often limited because it is confined to the page in which the injection occurs. Here things are different. We have an entire browser at our disposal. Yeah. For the remainder of this paper, we will assume that the reader is familiar with the fundamentals of CSS-based data exfiltration. Briefly, though CSS cannot directly read or transmit the contents of a page, it can conditionally trigger network requests based on the presence or value of DOM elements. For example, if an input field is known to begin with the letter A, selectors such as input value can be used to load an external resource. Yeah. If the selector matches, the browser uses a request to allowing the attacker to infer that the condition is true. The same principle can be used to determine whether a value ends with a specific string, using that one, or whether it contains a given substring. Yep. In the latter case, the selector only reveals that the substring is present somewhere in the value without indicating whether it appears in the beginning, the end, or anywhere in between. By repeatedly evaluating carefully crafted selectors across multiple CSS payloads or page reloads, an attacker can gradually recover sensitive information one character or attribute at a time. In its simplest form, this process requires the page to be reloaded between each iteration so that a new CSS payload can be evaluated. For example, once it has been determined that the first character is A, the page must be loaded with a different style sheet to test whether the second character is A, B, C, and so on. Without a mechanism to repeatedly evaluate new selectors against the target page, which there are so many great solutions for this, the amount of information that can be extracted remains severely limited. What? In our case, however, we do not have that luxury. We have neither HTML injection nor the ability to embed iframes. Instead, our only primitive is pre-existing static CSS files packaged inside the CRX and loaded as part of the GX mod. Why can't you do sequential import chaining? Here we go. Okay, that's where we're about to talk at. Okay, look at the sky. Another constraint is falling. A well-known technique discovered by Pepe Villa. Is this the original talk on sequential import chaining? We'll see. And Dona, yeah, let's see, yeah. Particularly proves useful in a scenario like this where it's not possible to reevaluate newly generated CSS payloads. This technique is known as import chaining, a CSS exfiltration method that leverages sequential @import directives to dynamically load new style sheets based on previously leaked information. Each imported style sheet is generated using the results of the previous step, enabling iterative character-by-character extraction of unknown data without requiring page reloads. It is a brilliant technique, but unfortunately does not work in our case. No! That's okay, we have other tricks. @import rules appear to be ignored. Why? This may be intentional, with the opera team deliberately preventing the attack vector, or it may simply be a side effect of how GXMod style sheets are processed. I want to see, I need a debugger attached in an explanation. That's crazy. One possible explanation is that the mod style sheet is concatenated with another browser style sheet before being applied. That would make sense, causing the @import rule to become invalid, as @import directives are only valid when they appear at the beginning of a style sheet. I don't like that this is left as an open question. Like that, I mean, if you're if you're performing security research, I would want to be doing SIC here because it would just be the easiest, and it's like, if SIC doesn't work, it's like, we need to figure out exactly why SIC doesn't work, and if it's something really stupid that we can just work around. Because, like, no. Like, give me SIC. Like, I want SIC. Any @import rule must precede all other valid @rules and style rules in a style sheet, ignoring @charset, or else the @import rule is invalid. Yeah, which it's Chromium based, so it'll actually do that probably. So that's an assumption that yeah. I also thought about a similar technique, a sort of mod chaining based on the same idea. The difference is that each step, the current style sheet would install a new GX mod. Yeah, you don't have HTML injection. There's actually a really interesting premise where you because what happens if you have an iframe with lazy loading and it doesn't get loaded until the CSS selector triggers, and then it doesn't install the GX. Now, you don't have HTML injection here, but maybe I guess if you had. Oh man, I don't want to know. All right, we're not doing this. Oh wait, does this? Okay, hold on. All right, I'm really excited here. This is really cool, but I have a feeling things aren't going to work out. The difference is that at each step, the current style sheet would install a new GX mod containing the next CSS style sheet, which would then be loaded and take over, and so on. The idea was based on the hope that a CSS selector capable of triggering network requests could be used to download a new GX mod by pointing its URL to a .crx file, just as we'd done previously with iframes. I'm saying 0 chance of this working based on my poor understanding of how Chromium different requests work. I'm going to say it's probably only like navigations, but since GX mods are installed automatically and their style sheets are automatically applied, replacing the previously installed ones, this approach could have worked. However, unsurprisingly, this was not the case. Yeah, it does not appear to be possible to trigger a download when the request originates from a static asset. Yeah, worth a try. Very clever idea. Defining the objective in the CSS cascade. Dude, yeah, having an objective defined would kind of rule. Like, that's definitely helpful for any attack or any security research. OperaGX does not appear to impose any documented size restrictions on CSS style sheets used by other mods. Are we static font leaking? Other than what the browser can handle before becoming unstable or crashing. Since the more elegant approach has proved unsuccessful, it's time to rack our brains a little and resort to a more barbaric solution. If this article doesn't talk about font leak, I'm going to cry, because font leak is it's so good. It's such a good pre-canned solution. It's like, usually in my experience I've had to make quite a lot of bespoke changes to it, but it's just such a great working thing to start from. Before diving into the core of the technique, we need to first define a target. We choose the following objective: exfiltrating the victim's Gmail address. Sure, this approach is by no means limited to this use case. Yeah, that's pretty reasonable. But that might be annoying, though, depending on where it's rendered, because there might be a stricter CSP. I don't know. Yeah, because Google likes to have CSPs because they care about this thing called defense in depth, and it's really cringe. So the initial idea was to find a Google page containing the Gmail address in one of its HTML attributes, so that the attribute could be targeted for exfiltration. Once this was achieved, we had to take into account a well-known CSS constraint that is reflected in its very name, cascading style sheets. The cascade is the fundamental mechanism that determines which style prevails when multiple rules apply to the same element. For our purposes, the relevant precedence rules are simple. The most specific rule wins, and when multiple matching rules have the same specificity, the last declaration overrides the previous ones. This becomes problematic in the following case. So, yeah. All three rules match the same HTML element, but they all assign a value to the same background image property. CSS therefore applies the cascade. Since the selectors have identical specificity, the last declaration wins and overrides the previous ones. Consequently, only a single request is issued, and the information carried by the other matching rules is lost due to collision. Yeah. To address this issue, it briefly crossed my mind to find a page that containing multiple HTML attributes whose values included the victim's Gmail address. This would provide multiple independent sources and in turn multiple exfiltration channels, background image, background, border image, etc., since the cascades only cause conflict when multiple matching rules assign the same property. Using different CSS properties allows multiple requests to be issued even when targeting the same element. Combined with the has pseudo class, this would make it possible to apply CSS rules to a styleable element such as HTML or body, based on the presence or content of another element in the page, effectively turning a non-styleable element such as meta into an exfiltration trigger through a CSS property that causes the browser to load a URL. Okay. The goal of this idea was to reduce CSS level collisions if several selectors match. So the problem is you're still going to end up with a character limit for how big of an email you can leak if you're like leaking trigrams, which I guess is where we're going. And then timing and reassembling those trigrams. I don't like that. Hey, like our Lord and Savior FontLeak wants to speak to you. Like, can we get? All right. This is okay. We'll see where this goes. But I have a feeling there's going to be some really clever and novel ideas here. So maybe it's best that FontLeak doesn't like. You don't just reach for the. It's cheesy, you know. You're like kind of cheesing the. All right. The goal of this idea was to reduce CSS level collisions if several selectors match at the same time, but write to the same property on the same element. The CSS cascade keeps only the last matching declaration, causing earlier exfiltration URLs to be lost. By spreading matches across different sources, target elements, and CSS properties, each match has a better chance of being evaluated through an independent channel, increasing the number of observable signals recovered from a single page load. CSS variables for collision-free wandering. We will spare you the many rounds of trial and error. After multiplying the number of sources and exfiltration channels reduced by the number of collisions, the approach was still not viable. Dang. Fortunately, after some additional research, I came across an elegant technique presented by Gareth Hayes. Is this the one where it's like the property-based one? No, this is older than that one. Alright. The idea was to use CSS variables and to store each match in a separate slot, slot 1, slot 2, etc., and then consume them all from a single property. For example, background image var slot 1, none, var slot 2, none, where none acts as a fallback when a variable is not defined. This prevents multiple matching rules from overriding one another and makes it possible to exfiltrate multiple strings in a single page load. Yeah, so, okay. That makes sense. That's actually, I don't think that I have this primitive in my mind when I'm thinking about these things, so, interesting. If both substrings are present, both variables are defined, and both URLs are loaded, okay. If BCD is not present, slot 2 remains undefined and none is used instead, okay. Theory and foundational approach. With the CSS collision issue resolved, the basic strategy is the following. Gmail addresses are composed of 37 possible characters, including the @ symbol. Okay, so we have a pretty well-structured definition here. I didn't know. That's a Google problem, not a me problem. Our goal is to define how the string starts, how it ends, and which sequence of characters it contains in between. Let X denote the length of the sequences we generate, bigrams, trigrams. Usually when you're talking about n-grams, you use n to just note. You don't have x-grams, you have n-grams. But, you know, I don't know. I'm just saying words I've heard. I don't know about math. Alright. A value that remains to be determined. We then generate every possible sequence of length x, resulting in a total of 37 to the x combinations. This requires 37 to the x CSS rules to determine how the string begins. 37 to the x CSS rules to determine how it ends, and another 37 to the x CSS rules to determine which substring it contains in between. Once the substrings have been exfiltrated, unordered, of course, we use a reconstruction algorithm that parses the received requests, or more precisely the query strings of those requests, to extract the starting sequence, the ending sequence, and the set of collected substrings. Then performs a kind of depth-first search, reconstructing the string one character at a time. Yeah, I don't understand how you resolve ambiguity in these. Like, if your exfiltrated string was just A, B, A, like, how are you... I don't think you have the fidelity to read that, do you? I don't know. At each step, the algorithm looks for an available substring whose length will be defined below, whose first x-1 characters match the last x-1 characters of the current prefix, extends the prefix by one character, and then continues recursively until the ending subsequence is reached. This makes it possible to reconstruct the complete string by relying on the overlap between consecutive substrings, as we will see shortly. So, no. Yes, for most cases, but isn't it very easy to have a case that just, if my email is aabaa@gmail.com, and let's go all full 37, whatever, pretend you don't know how to place this trigram, and there's no, you're gonna have multiple viable solutions. I don't understand how this works for strings with a lot of repeating characters that don't allow you to I don't know. Skill issue on my part. Do I not understand something here? I don't know. But this is why I always try to avoid n-gram-based exfil unless I know I can get away with it, because of, by definition of whatever I'm trying to leak, it won't have more than 3 of the same character in the row. Because otherwise it's ambiguous, right? I don't know. Maybe there's a magic trick I don't know about, but I can't imagine what that would look like. Quadragrams. We can already rule out bigrams, although they would result in a relatively small CSS style sheet containing only 4107 rules. They're simply not suitable for reconstructing the string, as they provide only a single character of overlap between consecutive matches. Yeah, you're going to have so much ambiguity. Our first instinct was to think big and try quadragrams, which would provide 3 characters of overlap during the reconstruction process. This ambition comes at a significant cost. 5 million rules for approximately 880 megabytes. Okay. Our expectations were close to 0, but we decided to test it anyway. Unsurprisingly, the style sheet was not even processed by the browser. Hey, at least we're not talking gigabytes. I would have tried it too. I would have been like, nah, I feel like the browser can handle that. Constraints forced us to give up elegance, but here it is. It's pure brutality. Okay. I don't... When do we do the font leak research review? I guess we have to now. Constraints forced us to give up, yeah, okay. Trigrams. The only remaining option was trigrams. They provide 2 characters of overlap for the reconstruction algorithm while requiring a significantly smaller number of CSS rules than quadragrams, 151k. Implementation and hitting the ceiling. After vibe coding a Python script to generate the style sheet based on our initial strategy, it looked like this. I think that there's a way that you can golf this. I had to golf some stuff that I can't talk about it, but I'm giving a private talk about it, which is cool. Okay. Yeah, so variable declaration section, 50k lines for declaration of the variable start. Yep, that makes sense. The latter will be populated with the value of the matching trigram as the query value, 50k lines for the declaration of the variable end. Yeah, because you need a head and a tail if you're going to be trying to resolve the trigrams. Oh man, that's such a mess. Yeah, okay. Same as before, except that the variable end will be populated by a URL. I would do $E, or even split it differently just to limit the... Because when you're repeating the same string, I would not be naming these end. I've spent too much time golfing these things, man, and I would not be matching. I guess if the browser's loading it, fine, it doesn't matter. But I'm character constraint, CSS character constraint trauma. Also, look at that. That's a space. You think we can afford these? Do you know how many times these spaces are repeated? That many. Think of all the bytes you say, which I guess it's not. If the browser's loading it, fine, it's fine. But man, I have so much CSS trimming trauma. All right. Same as before, except that the variable end will be, yeah, okay. 50k lines for variables ranging from T1 to them for all possible trigrams between the beginning and end of the string. Variables corresponding to existing trigrams will be populated with the corresponding URLs, while the others will use none as a fallback. I need to understand that trick better. Like, you're setting multiple variables, and then what is the ultimate final exfil? Is it all of them? Okay. Variable consumption section. The variable declaration section is followed by the consumption phase, in which every variable is referenced from a single background image declaration applied to the HTML element. This causes the browser to attempt to load every URL stored in the variables that were defined by matching selectors. Okay. Well, none acts as a fallback for variables that were never defined whose trigram did not match. There we go. Okay. Nice. So that's the ultimate Oracle. Okay. After packaging the style sheet into a .crx and installing it as a gxmod, the first test was not successful. Few requests were issued before the page eventually crashed completely, which was hardly surprising given the number of variables referenced from a single CSS property. Oh man, rip. Page crash due to excessive lack of elegance. I forgot. I love the zero write-ups because he always has bangers like this. Yeah. Unlike the quadrigram experiment, the CSS style sheet was successfully processed and a few requests were issued before the page eventually crashed. That was an encouraging sign. A few adjustments were needed to reduce the load until every request could be issued reliably. Okay. After several more attempts that either worked only partially or crashed intermittently, great. Two ideas came to mind that significantly reduced the load. Multiplication of sources. Multiplying the number of sources by finding a page where their Gmail address appears as the value of multiple HTML attributes. For this purpose, we used some page that... What's the CSP look like? I'm actually going to open it in a window that I'm authenticated in and see what does the CSP look like. So yeah, that's the thing I'm concerned about. Okay. There's no image load restrictions, so that's fine. Okay. Alright. Because, like, you know, yeah. Okay. So there we go. So it's included in a meta tag as the content value. It's included in a list item as a data ID attribute, and it's included in some input as value, and a fixed value, so it's actually selectable by CSS. From the Google HTML page, there are additional attributes containing the address, but they also include other information, introducing too much noise. Probably. We can now split the real variable declaration phase as follows. The start 50k rules and end 50k rules declarations are applied to the meta element. The TN declarations 50k rules are split evenly across the three available sources. This is an interesting way of being able to split this. This is really cool. Okay. And then okay, yes. Wait. Okay, so start and end are applied to the meta element, and then the TN are split across them evenly. Splitting the consumption phase. The second optimization targets the consumption phase. In the initial version, all 50k variables are referenced from a single background image declaration in the HTML element, requiring the browser to evaluate over 50,000 CSS layers simultaneously. Man, I want to pull font leak-esque ideas into here. Especially like anything involving CSS animations to be able to, you know, reduce the simultaneous load. But okay, to reduce this per property load, the consumption is split across 3 independent declarations. So you throw one on HTML, one on body, and then one on the HTML before pseudo element. Each of these declarations now references approximately 17k variables instead of 50k, reducing the number of CSS layers evaluated per property by a factor of 3. So that the question is, how does the backing implementation work, and does this scale? Like, is this a major difference? Is it like ON squared of that, or is it just... I don't know. I'm curious what the difference looks like in the backend, or the backing Chromium Blink code. But also it does not matter, because who cares, lol. Since each declaration targets a different element, there's no cascade conflict between them. The variables assigned to HTML body and HTML before are consumed independently, and none of their respective background images values interfere with one another. Combined, the multiplication of sources and the splitting of consumption phase brought the total well below the threshold at which the page would crash while preserving full coverage of the 50k trigrams. Nice. String reconstruction algorithm, yeah. So this is, I mean, n-gram solvers are, I mean, I'm sure you can import some Python module. It's an n-gram solver, and just feed it the parameters. But after verifying the trigram extraction worked reliably across multiple devices, it was time to tackle the string reconstruction algorithm. Why? The algorithm takes an input log of, like, it's fun, it's cool, but it's like, whatever. I'll get into that reflection piece at the end of this, because this is, an algorithm takes an input, as input, a log file containing the HTTP request received on the attacker's host. Following a single visit to the target page, I would have abstracted it. I would have I would have put it in just normal n-gram terms instead of like that. I would have parsed out starts, ends, and whatever. It begins by parsing the query string of those requests to extract the 3 pieces of information. Yeah, this would have been its own module. That would have been, whatever. Who cares? Why are we picking at implementation? The start value, the first 3 characters, and the end value, the last 3 characters before @gmail, and the set of all trigrams collected via the middle selectors. Starting from start, the algorithm looks at each available trigram and checks whether its first 2 characters match the last 2 characters of the current prefix. If they do, the prefix is extended by 1 character, the 3rd character of the trigram, and the process continues recursively. A path is considered valid when the current prefix terminates with end. Nice. Yeah, so in this case, we have one solution. All valid paths are recorded as candidates and printed at the end, sorted by length. Okay. A budget for problems. One subtlety worth addressing is repeated trigrams matched by the star equals selector. Okay, so we're addressing the fact that there's unsolvable trigrams here. These selectors are Boolean. They fire if a substring is present at least once, regardless of how many times it appears. Each corresponding tn variable is therefore set at most once, and only one request is sent for that trigram. For example, hey.cow, cuckoo, I don't know, shout out my boy Couscous, contains cow twice, but produces the same signal as an address where cow appears only once. The reconstruction algorithm has no way to know whether the trigram occurred once or twice. Yeah, exactly. So, yeah, that's a good point. Oof. Yeah, I didn't even think about that. I thought about where we don't know where to place it because it's so ambiguous, but that's a valid point. Is there a way to leak length of an attribute trivially? Because that could be its own signal. That sounds reasonable. I feel like you could just have select. Can you just I don't know. Yeah, I actually don't know. I'm not sure. Because if you just leaked the length, then it would make filtering these repeated ones easier. The same trigram may still be exfiltrated separately through start, end, but that does not reveal how many times the substring appeared in the local part. To handle it, each trigram is assigned a budget of 2 uses within a given search branch. This allows the algorithm to reuse a trigram up to twice during reconstruction, covering the most common repetition cases without causing the search space to explode while listing every valid candidate when multiple reconstructions are possible. Regular trigrams are allowed a budget of 2 because star equals only tells us whether a substring is present or not how many times it appears, whereas end is extracted with a dedicated end selector that identifies the final suffix of the local part, so it's capped at 1 use by default to keep it as a single closing anchor rather than a reusable middle trigram. Yeah. Every time a trigram is selected to extend the current prefix, its budget is decremented. When it reaches 0, it is no longer available for that branch of search. Since each branch carries its own copy of the budget, backtracking correctly restores the available trigram for sibling branches. Example, with start equals ACI and 2 possibilities to choose from, ACI, CII, or CIL. There's our budget. Yep. If the branch ACI, CII leads to a dead end and no available trigram overlaps with the current prefix to extend it further, the algorithm backtracks and can still try ACI, CIL. Only the copied budget used by CII branch was modified, while the budget at the ACI level remained unchanged. If, after reconstruction, some trigrams remain unused and those trigrams are not part of @gmail.com, are you selecting this? Why would you select this? I thought it would end at that. Okay, the algorithm treats the result as incomplete rather than final. Huh. It then increases the end budget and runs the reconstruction again on the assumption that the final 3rd character suffix may also appear earlier in the local part, the segment before the @ symbol, and was consumed too early during the first pass. This is a reasonable compromise. In most cases, the first reconstruction of the end capped at 1 use is already correct, and retrying only when used non-gmail.com trigrams remain avoids making the search more permissive by default. In a few cases where the initial result is too short, allowing n to be reused gives the algorithm a second chance to connect the leftover trigrams into a longer, more complete candidate. With this model, an address like energy.ner@gmail.com containing ner twice, where one of the two trigrams is at the end, can still be retrieved successfully. Oh wow, so he's exfiltrating the gmail.com, which is like, you'd think that you wouldn't do that for this, because you'd be like, we know that that's where this, we know it's going to be at gmail.com, we're leaking a Gmail address, why are we leaking additional characters? And maybe you use this to anchor your end selector, that's the only... Yeah, I don't know, it's an interesting... Okay. With end budget equals 1, the solver uses ner immediately after n to build inner, which already ends with the expected suffix and is therefore accepted as a valid reconstruction, even though several middle trigrams remain unused. When the algorithm later detects that those unused trigrams do not belong to @gmail.com, it retries with a higher end budget, allowing ner to be consumed a second time and making it possible to continue the path all the way to energy.ner@gmail.com. Yeah. Interesting. It's a bespoke trigram solver for this specific case that tries to have some heuristics based on the known structure, which is, it's about getting the bug working, not getting the bug working with the least effort, or with the best pre-canned solutions. Zero click, and I'm sure it's fun, to write a trigram solver, especially one I don't know. I just don't like the the lack of info, the fact that there's strings we can't exfil with this, and it's it's sad, and it's when I already know that there's a more a solution that won't run into these issues, it's hard for me to want to do this. Zero-click XSLeak via universal CSS injection. When the victim visits a website embedding an iframe whose source points to the malicious.crx, the GX mod is installed within a few seconds. However, as mentioned earlier, a notification bar appears below the address bar informing the user that a mod has been installed. This notification includes a remove button, allowing the mod to be uninstalled without opening the GX mods interface. From an attacker's perspective, this is rather inconvenient, as it would require hoping that the victim does not remove the mod and that it remains installed until they eventually visit the target page chosen for data exfiltration. Fortunately for the attacker, since the mod is installed within seconds after the user lands on an attacker's website serving the malicious CRX, only a few lines of JavaScript are needed to start a short timer before automatically redirecting the browser to the desired page, Google contact email in our case. In other words, by the time the user reaches the attacker's website, it is already too late. The mod has already been installed. The browser is immediately redirected to the target page, and the data exfiltration takes place before there's any opportunity to remove it. To summarize the attack, the victim visits the attacker's website. The mod is installed without user interaction. A redirect is performed without user interaction. The trigrams of the victim's Gmail address are exfiltrated to the host controlled by the attacker. The exfiltrated trigrams are fed into the string reconstruction algorithm. The victim's Gmail address is reconstructed. Although we chose to demonstrate the technique by exfiltrating the victim's Gmail address, as part of this proof of concept, the attack is by no means limited to this particular use case. We also encourage readers to explore the broader capabilities of CSS injection, especially the fact that CSS-based exfiltration is not nearly limited to values stored in HTML attributes. That's true, you can leak DOM nodes, or DOM content as well, with very tight CSPs even, as long as you have a signal. If you can get font load or image load. Or, I guess if you could get style load, but we're saying tight CSP, whatever. The tests presented in this paper were performed on version 127 on MacBooks, more than one, and a Windows machine. Conclusion. In this paper, besides a denial of service vulnerability caused by driving the browser into an unexpected state, we demonstrated how the seemingly harmless ability to automatically install GX mods by simply visiting a web page can be weaponized to build a zero-click universal XSLeak. I just had an interesting DoS thought that's not relevant to this at all. Okay. Well, GX mods expose only a limited customization interface and do not support JavaScript execution or extension permissions. Their ability to inject attacker-controlled CSS into every web page visited by the user gives the CSS access a far broader browser context than traditional CSS injection vulnerabilities. The vulnerability was reported through BugCrowd, the platform on which Opera runs its bug bounty program. The vulnerability was initially difficult for BugCrowd analysts to fully understand. Yeah. And after a few messages explaining the attack, the report was eventually triaged as a P3. Sad. In the meantime, we received the trigram of one of the analysts who was attempting to reproduce the endpoint on the exploit on our endpoint. Using the reconstruction algorithm, we were able to recover the analyst's Gmail address and left it as a comment on the report, which may have helped convey the severity of the vulnerability. Opera security team ultimately assessed the vulnerability as a P1. Nice. That's good, because it's a pretty sick bug. And awarded the maximum bounty available for critical vulnerabilities. 5K. Okay. Really? Okay. Oh, okay. So, like, oh, okay. Timeline, this was this year, yep. A report sent via BugCrowd, uploaded to the PSC with a more efficient CSS reconstruction algorithm, triaged by BugCrowd security analysts a month later. Acknowledged by Opera security analyst, vulnerability patch and bounty awarded, severity update P1, nice. We would like to thank the Opera security team for their responsiveness throughout the disclosure process. They quickly put us in direct contact with the appropriate people and ensured the entire process was smooth and efficient. Thank you for rating. Research conducted by Zhero and Inzo, published July 2026. And then if you want to sponsor them, I'm a pretty crazy researcher, right? Okay, yes. So I have a lot of thoughts here, but we'll hit the research review points. Let me go find the documentation I wrote on that. How does this generally apply to bug bounty? Really cool, like revisiting some interesting past research and being like, yeah, I wonder if they fixed that. Just looking at like from Renwa's write up and being like, yeah, that's interesting attack surface. I wonder what's going on there now is always interesting. And then obviously, like, you know, having CSS exfil tricks really useful for bug bounty because a lot of that stuff is developers don't understand the risk of like injecting arbitrary style sheets necessarily, and it can happen places, especially places with sensitive information. So knowing the attack primitives and knowing the tricks for exfiltrating content and where the current research limitations lie is really nice. Where else can this be applied? I mean, honestly, so... I'm sure there's more interesting attack surface here, and there's CSS injection all over the place, and it can have interesting impact. Why did this work? I mean, why does anything Zhero does work? That guy is very deep and is very good at taking apart and understanding things, but in this case, it was a very clear line of like, yeah, this isn't safe, and then it was a matter of actually weaponizing it to show impact. What further research should be done here? Yeah, so, and we might do a proper research review on this, but enter FontLeak. So FontLeak, without getting into all the details, the dynamic option without figuring out a workaround for add import blocking might be tricky. However, the static option would work in this scenario just fine. And the spot I want to see further research is this right here. Essentially, there's a much more stable way to do static leaks with a scroll container trick, which is not implemented in FontLeak yet, and it would work so much better than the existing static implementation. And I would love to have seen Zhero take this, run with that, and build a super stable fork or patch for FontLeak to use scroll container tricks for such beautiful stable static leaks. Yeah, that's the further research I want to see here. But yeah, so FontLeak would have allowed for performing the desired leaks here without needing to do this ambiguous trigram or just ambiguous n-gram resolution. So the static FontLeak would have had to be used. Whatever. Maybe we'll do a research review on FontLeak, but it's just like such a foundational. When you need it and it works, and you're able to get it working, and you're able to exploit such a tight-looking CSP and such a like limited-looking injection, and still be able to leak a whole session token semi-reliably, it's like, dude, this is crazy. All right, conclusion. I like that maybe I like that it didn't use a pre-canned solution and that it went for, implementing your trigram solver is fun, and using the tricks to kind of whittle down the size of the complexity of the injected styles is cool. I rate this X gram out of 10, which I don't know what that means, but I never know what the ratings mean. So yeah, good write-up, definitely. Always cool to see zero research, and I always like the way things are described. So we'll call this research reviewed.